So after all of our preparatory work with basic review of geometry, parallel lines, similar triangles, all the basic review of the work we've done so far, we now come to really the big deal of this first chapter, the first part of our course. We're going to give the definition of the trigonometric functions. It turns out there are six basic trigonometric functions. And really a lot of trigonometry amounts to is that the entire course is you take these six functions and you just go crazy with them. These functions they have properties of every other function you've ever studied. I'm going to assume that you have already been through a course where you have studied functions, you've worked with functions, you understand the notion of functions, the language of functions, arguments and domains and whatnot. And so I'm going to assume that you've been through a course with functions. If you have not, then you need to really get out of this course pretty quickly, because a huge amount of what we're going to talk about is not going to make any sense to you. So I'm going to assume that you've been through a course where you've dealt with functions before. These functions they're just like any other functions. They have domains, we'll talk about later. They have ranges, we'll talk about later. They have a graph, we'll talk about later. They have inverse functions, we'll talk about later. So these functions are the same as any other functions in that regard. But they're very particular functions, and they have some special properties that they share amongst themselves, and that's what a lot of the course is about as well. For now, we're going to just define these functions and give the rules for what they actually mean. Now, let P x comma y. So let a point be given. A point P. So we're given a point in the xy plane. It may be any point you wish, with one exception. We assume P is not equal to the origin. So any point other than the origin. It can be, remember how we have quadrants, right? We have quadrant 1, quadrant 2, and so on. It can be in whatever quadrant you like. It can be lying on one of the axes if you like. Any point given in the plane is allowed. And so we are given the value for x and value for y. Just to illustrate what's happening here, there's nothing magic about what I'm choosing. I'm just going to randomly select. Suppose my point P, x comma y, is here. This coincidentally happens to be, in this case, in quadrant 2. There's nothing that requires that. I'm just randomly selecting a point in the plane. Now, the next piece is this. From that given point, you draw two line segments. One of them is you draw a perpendicular to the x-axis. In this case, it drops down to the x-axis. If we were down here below, you would have to elevate and raise, but you draw a line segment from the given point to the x-axis, perpendicular to the x-axis. The second segment you draw is from the given point to the origin. It should be clear that no matter what point we pick in the plane, we can always do that. Now, there are a couple special cases. Suppose the point we select actually is on the x-axis. We will look at this in a little bit more detail later on. But when we draw the perpendicular, well, there is no perpendicular. The point itself is the perpendicular. When we draw the segment to the origin, we can do that. That's this. And so this is sort of a special case. We will talk about what happens if the point lies on the axes. We'll talk about that in a little bit different later on, in a little bit different context. But for now, just kick that can down the road, and we'll deal with that later. For now, this is my point P. Drop a point to the drop a segment to the x-axis, and draw a segment to the origin. Now, the next piece is this. We label, because this is a perpendicular, we now have a right triangle. And we label the two legs. Remember that any right triangle has a hypotenuse and it has two legs, the legs and the hypotenuse. a couple things we know, and this is going to be throughout the rest of the course, it's always the case, we know that it is not possible for these legs to be longer than the hypotenuse. I've used some terminology. The hypotenuse is the side opposite the right angle. The hypotenuse is the side opposite the right angle. So when we draw the segment from our point to the origin, that segment is the hypotenuse. We're going to label that segment. This is the standard procedure. Everyone else in the world does it this way. You might as well join the club. We're going to label this not with the letter H for hypotenuse. We're going to label this segment with the letter R. Join the club. Everybody does it that way. You might as well be with everybody else. Here's why we label this R. Later on, we're going to do this. We're going to take a circle centered at the origin and passing through that point. We're going to draw, eventually we'll draw the entire circle. That's what we're going to do later. Not now, not yet, but that's one thing we're going to be doing later on. When that happens, this hypotenuse becomes the radius of that circle, and that's why the letter R is chosen for that hypotenuse, not the letter H. It's just a style thing. It's just the way everyone does it. And since everyone does it that way, all the textbooks write it that way, you might as well join the club. So let's forego that for now. That's sort of preview of coming attractions. Now, the legs are the other two sides. There's the hypotenuse, which is opposite the right angle, and then there's the other two sides. Those are called the legs. The legs values are given by these coordinates. Let us just pick up some numbers out of the blue sky. This might be, what might this be? We know we're in quadrant 2, so the x coordinate's got to be a negative number, and the y coordinate's got to be a positive number. So this might be the point. Again, don't write this, just think with me. This might be -5, 3, or this might be -7, 2, over 7, negative, and up 2. It might be any value, but see, the x value is negative, the y value is positive. If I had, 10 minutes ago, if I had chosen my point P to be down here in quadrant number 3, if I had chosen P to be in quadrant number 3, then both the x value and the y value would be negative. If I choose the value to be in quadrant 4, the x value is positive, but the y value is negative. So the positive negative of x and or y depends upon which quadrant we're dealing with. I just randomly chose quadrant 2, and so in this particular case, x happens to be a negative number. When I label these sides, I am not going to label them with the distance. Distance cannot be negative. I'm going to label them with the coordinate. I'm going to label them with the coordinate. Some would argue you could introduce a notion called directed distance. We're going to forego that. I'm going to label the coordinate. The coordinate here is x, but we need to remember x is now a negative number. I'm going to label this with the coordinate y. In this case, y happens to be a positive number. If 10 minutes ago I had chosen this to be my point P, x would be positive, y would be negative. If I had chosen this to be point P, x is a negative number and y is a negative number. I don't need to put a negative value in front of that because x is already equal to a negative value. So that's my triangle. No matter what point we select, we can draw the perpendicular to the x-axis, always, always, always. Perpendicular to the x-axis. Perpendicular to the x-axis. Always draw the perpendicular to the x-axis. Never, never the y. Always draw the perpendicular to the x-axis. And then draw the segment from the point to the origin. That hypotenuse is labeled R. This is the x coordinate. It might be a negative number. This is the y coordinate. It might or might not be a negative number. All right? But so what have we been given in this problem? In this problem, these two numbers are the only two numbers we have been given. The only two numbers we've been given are x and y. We can find the value of r. R is not given. We compute r. And so, we know we can use Pythagoras. At its heart, at the very, very deep inner core, the inner sanctum of trigonometry, is the Pythagorean theorem. At its core, everything in trigonometry is fancy schmancy Pythagorean theorem. So we're going to use the Pythagorean theorem to find the value of r. We know that r squared, the hypotenuse squared, is equal to leg squared plus leg squared. Right? That's Pythagoras. But I don't want to find r squared. I want r itself. I want to find r, not r squared. So to get rid of the square, is it clear what we need to do? This implies the square root of the left is equal to the square root of the right. However, what I have written here is not, strictly speaking, accurate. Actually, what I should write is this. Because we know that if you take the square root of a number, it could either be the positive square root or the negative square root. Remember the plus or minus in the quadratic formula, x is equal to negative b plus or minus square root, comes from the same place. And so we need to introduce the plus or minus. However, and this is what we will do now, once, forevermore, and then we won't have to deal with it ever again. When we do this construct, we assume. So we make one assumption. One assumption is that the point we choose is not the origin. The other assumption we make is that r is greater than 0. R is greater than 0. It is always greater than 0 because that is an assumption we've made. We assume r is greater than 0. And so from that, then we see when we do this computation, yes, potentially it could have been plus or minus, but because of this extra assumption, we have r is equal to the square root of x squared plus y squared, the positive square root. So what we have is, again, I'm going to write this down here a little more clearly. R is given by the square root of x squared plus y squared. R is the square root of x squared plus y squared. You will use this notion over and over and over and over and over again. R is the square root of x squared plus y squared. X could be positive, it could be negative. Y could be positive, could be negative. R is always positive. And so that's, so far, that's what we have for this. And then we'll be doing a lot more detailed work with this when we talk about the functions themselves. So far, that's what we have. Given a point x comma y, we can find this right triangle, which means we can use Pythagoras. And we have x, we have y, we have r is equal to the square root of x squared plus y squared. So far, so good.